Geometry, section 10.2, area of trapezoids, rhombuses, and kites. The area formulas you see here go for those three figures. Trapezoid is 1/2 times height times the sum of the two bases. The bases are the parallel sides. The area of a rhombus and the area of a kite are actually the same formula. Area is equal to 1/2 times the first diagonal times the second diagonal in any order. Okay, so a couple things about these diagrams. First of all, a trapezoid, we learned in chapter 6, is a quadrilateral that has a pair of parallel sides. That's how it's defined. And it has really nothing else. There's nothing else parallel. If it had two pairs of parallel sides, that's a different figure. That's a parallelogram. So it has to have exactly one pair of parallel sides. We did define an isosceles trapezoid in chapter 6. And yeah, this formula would work for that too. So if we can find the area of a trapezoid, of course, we can find the area using the same formula of an isosceles trapezoid. Rhombus is defined as a side, as a quadrilateral as having 4 congruent figures. So if that were the case, then you'd have some kind of markings on the picture that would look like this. 4 tick marks that are all the same measure, showing that all those sides are the same measure. If it were a kite, then you might have 2 tick marks like this, and then 2 more tick marks like this to indicate that they are different lengths, but that adjacent sides are the same length. Okay, but in either case, in either way, it's the same formula, whether it's a rhombus or a kite. Okay, so a few examples. Car window is shaped like the trapezoid shown. Find the area of the window. So here we have a trapezoid, very simple example just of how to use the formula. 1/2 height times the sum of the bases. Some of you might have a question about these formulas and, would we make you to memorize these formulas? Yes, if you were here, we would be making you memorize almost all of the formulas. I think there are 3 that we end up giving you in chapter 10, but many of them, all of the ones from section 10.1 and these 2 in section 10.2 would be formulas that you'd memorize. I always kind of issue a challenge to the class and say, come to me after you do the homework and tell me you didn't memorize the formulas, right? Because you did. If you do the book work, by the end of it, you'll know the formulas. So it's not really a memorizing situation anyway. Anyway, the height is always perpendicular to a base. In this case, you have 2 bases, so it's going to be perpendicular to both. Those right angles are shown. So the height is the 18. The bases are 20 and 36. And then you would just use your calculator from here. 1/2 of 18 is 9, and 20 plus 36 is 56. So really, I'm just typing in 9 times 56 on my calculator, which would be 504. Always a work and answer situation, right? So work is this line right here. You don't need to show the formula, obviously, but the work would be this line right here, and then the answer would be 504, and it's an area, so that would be inches squared. Here you have a trapezoid, also a little bit of more of a challenge in that you are not given the height. The height would be this line right here, this line segment. Just the same then, you could draw down there and we'll call that H. And the reason that I would do that there is because now I've created a triangle situation. So really what I've created is a triangle and then also a rectangle here. So this being 11 would make this 11 and would make this 5. And I mentioned in the previous lesson that sometimes there's confusion about, is that 16? Is that talking about the whole thing, or is it just part of it? That confusion can come in here because you draw that line in, and now, if you're not careful, I don't think it's confusing, but if you're not careful, you could accidentally mistake the partial length for 16 when really the 16 is the whole thing. Anyway, because this is 5, you could find H using the Pythagorean theorem. H squared plus 5 squared equals 13 squared. If you solve this for H, you'd find out that H is 12. That's a common right triangle. 12 squared plus 5 squared does equal 13 squared. Okay, and then once you do that, then it's the same as the last problem. 1/2 the height, which we just found to be 12, times the sum of the bases. Again, make sure you use 11 and 16 as the 2 bases. 11 is the length of AB, 16 is the length of DC, and then we want to just use our calculator from here. And again, a little bit of mental math there. I know that 1/2 of 12 is 6, So I'm really multiplying 6 by 27. 11 plus 16 is 27. And we get 162 feet squared. Just confirming there, 162 feet squared. Okay, next example. Here you have a kite. It could be a little bit confusing. They're saying the 1 is this length right here. That's the 1. And anyway, the area of a kite and a rhombus, but here we have a kite, is 1/2 diagonal 1 times diagonal 2. It's denoted by the subscript notation. And 1/2 of diagonal 1, let's do xz as being diagonal 1, that would be 6. And then diagonal 2 would be 1 plus 4, which is 5. Okay. Another common, kind of pitfall here is to think and use the 3 rather than 6. Well, the diagonal goes all the way across. The diagonal is from one vertex to the other. And one of them is xz, the other one is yw. That's 1 plus 4, which is 5. 1/2 of 30 then is 15 centimeters squared. 15 centimeters squared. And then here you have a rhombus. Notice that the second diagonal is not drawn in. Now we did learn back in chapter 6 about rhombuses that their diagonals do bisect each other. In fact, to be exactly accurate, a rhombus is a parallelogram, and a parallelogram have diagonals that bisect each other. Just to say now, because we'll use this here before we're done, a rhombus additionally has diagonals that are perpendicular to each other. Okay? So as I draw this diagonal in, not only does it cut this 24 into a pair of 12s, there's also a right angle between the two diagonals, which means, again, we're going to be able to use some right angle properties, namely the Pythagorean theorem. So if I call this length right here, which is unknown at the moment, if I call it x, then I can do x squared plus 12 squared equals 13 squared. You follow? Here's a leg length. Here's a leg length on a triangle. And then 13 is the hypotenuse. X squared plus 12 squared equals 13 squared. And a little bit, not quite enough diversity in problems because, again, they're using the 5, 12, 13 like they did on the last example. If you solve this, you'll find out that x is 5. Okay? Now, again, careful because the diagonal is not 5. The diagonal is 10. If one of the diagonals was already given to us as 24, the other diagonal is twice 5. We just found this length, the diagonal goes all the way across, that's double, it's going to be 10. And your area formula, again, if you were here and I were emphasizing work, I'd be talking about this line of work right here. 1/2 of 24 times 10. And that would come out to 120 feet squared. That's an area, 120 feet squared. Okay, a couple more things. Back to my starboard here. Quick reminder that you learned in section 8.2 about special right triangles. We're going to use these in just a second, so make sure you remember that on a 30, 60, 90 right triangle. And I would know that this is a 30, 60, 90 right triangle by the triangle angle sum theorem. Here's 90 and here's 60. The 3 have to add up to 180, so that would make this a 30-degree angle, 30, 60, 90. This would be the short leg because it's opposite the smallest angle. The short leg times root 3 gives you the long leg. And the short leg times 2, that says 2s, not 25, that says 2 times s. The short leg times 2 gives you the hypotenuse. This is just the truth. This is just always true on the 30, 60, 90 right triangle. If I'm given the short leg, I can multiply it by root 3 and I'll have the length of the long leg. If I'm given the short leg, I can multiply it by 2 and I'll have the hypotenuse. Similarly, though, if I'm given the hypotenuse, I could cut it in half to get the short leg. If I knew the long leg, I could divide it by the square root of 3 to get the short leg. There's a relationship between all these sides. Same thing, or not same thing, but similar relationship on the 45, 45, 90 triangle. It's actually an isosceles triangle. So if this is a side, then this is a side. And the relationship to the hypotenuse is the side length times the square root of 2. We learned all that in section 8.2 if you want to review that. All right, I'm going to need that here here's a problem. I forgot to label it. Let me put those in real quick. Here's a length of 12, and the whole length here is 20, and these are a couple of right angles. And again, they want us to find the area. And let's also, this angle is 60 degrees. That's a 6. Okay, so we're trying to find the area of that figure. And what you're going to want to do is draw on the figure like you saw me do a minute ago. Draw on the figure itself like so, and make yourself a 30, 60, 90 right triangle. And if this length right here, which is 12, is the hypotenuse of that triangle, well, that would make this length right here to be 6. It's half the hypotenuse. Okay, again, we reviewed that up here. Now we're using it. The hypotenuse cut in half gives me the short leg. That length, short leg, times root 3 would give me the long leg. And that long leg is actually the hypotenuse, is actually the height. It's not a hypotenuse, it's the height of the trapezoid we're trying to find. Also, if this length is 6, out of the whole length that is 20, that would make this 14. And we need that length as well to now go ahead and plug it into our trapezoid formula. So the work to be shown, and I think there's work to be shown up here, and sometimes you have to use the Pythagorean theorem, and yeah, that's work that you should show out too. But the work that I'm always looking for when I'm grading this stuff is this right here. 1/2 of 6 root 3 times the sum of 14 and 20. And half of 6 would be 3 root 3. If I could just simplify this a little bit, 3 root 3 times 34. And then you want to use your calculator. A lot of times we'll say simplest radical form, and I think you'll see that in your homework today. So really all I'm going to do is multiply 3 times 34, which is 102. If they wanted it to the nearest tenth or nearest whatever, then yeah, you're going to want to use the square root of 3, the square root button on your calculator. But actually, a lot of times they'll just say simplest radical form. This turns out to be 102 root 3. And that's an area. Now, the units weren't given. If we went back here and this was in centimeters, then of course we know that this area is in centimeters squared. Okay, one more problem. Here we have, let's say it's it doesn't matter, it could be a kite or a rhombus. Actually, let's say it's a rhombus. So it might say in the directions that it's a rhombus, or you might have 4 tick marks like this. Immediately what I can assume is that this length is also 6 and that we have a right angle because the diagonals bisect each other and because the diagonals are perpendicular to each other. Then what would happen is that these two lengths, pick either one and look at a triangle, either one of those lengths, they're going to be the same, would be 6 divided by the square root of 3. Okay? Now, if they were asking for this to the nearest tenth or the nearest whole number, the nearest thousandth, you could just use 6 divided by the square root of 3. Again, a lot of times they're going to say simplest radical form. So it would be worth the time right now to go ahead and change that to simplest radical form, by multiplying by root 3 over root 3 to change it into, the word is escaping me right now, but it'll come to me. 6 root 3 over 3, which is 2 root 3. Rationalized denominator is what I was trying to think of. Make it to have a rationalized denominator. Both of those lengths are 2 root 3. Okay, now don't check out on this last part. Before I use the area formula, each of these lengths, like partial lengths of the diagonal, is 2 root 3. The whole length would be 2 root 3 plus 2 root 3, which is 4 root 3. So as I pull into the area formula, one of the diagonals is 12, 6 plus 6. The other diagonal is 4 root 3. So the area formula then, I really shouldn't circle that like you think that's the answer, but I'm going to use these two things. The area formula then is 1/2 of 12 times 4 root 3, which would be 24 root 3. And again, units weren't given, but if this was 6 miles, this would be 24 root 3 miles squared. If they leave units out, then you don't have to include units either. All right, thanks for watching.